Good day. Today we're going to discuss Introduction to Logarithms. Now, when we say logarithm, let a and b be positive real numbers such that b is not equal to 1. The logarithm of a with the base b denoted by this symbol, so that this symbol should be read as the logarithm of a with base b, is defined as the number such that b raised to the power of the logarithm of a to the base b is equal to a. That is, the logarithm of a to the base b is the exponent that b must be raised to produce a. Now, let's have some properties of logarithm. Now, property 1. The logarithmic equation can be transformed to exponential equation and vice versa, as illustrated below. So, the logarithm of a to the base b equals x, can be transformed as b raised to x equals a. Now, it is colored for you to be guided that this subscript is actually the base, and this portion is the exponent, and this argument is this number. Let's have an example. Transform the given logarithmic equation to exponential equation. The logarithm of 125 to the base 5 equals 3. Now, as on the previous slide, this subscript becomes the base, this is the exponent, and this is the answer. So you have 5 raised to 3 is equal to 125. Let's have another example. The logarithm of 81 to the base 3 is equal to 4. So this is the base, this is the exponent, and this is the answer. So in other words, you have 3 raised to 4 is equal to 81. Now let's have another example. Determine the value of the logarithm below. So you have the logarithm of 32 to the base 2. Now, let's have this kind of mentality. Let's say that the value of this logarithm is x. So you have the logarithm of 32 to the base 2 is equal to x. Now, from the previous slides, this would be the base, this is the exponent, and this is the answer. So you have 2 raised to x is equal to 32. Now, from the concept of exponential equation, now we are going to make the two numbers with the same base. So what would be the number that you have to multiply it by itself? The answer would be 32. Something like, what would be the number that was multiplied to itself by certain times? Then the answer is 32. So you have 2 raised to 5. So since they have the same base, by the way, 32 is equal to 2 raised to 5. We have 2 times 2 times 2 times 2 times 2 is equal to 32. Now, since they are now on the same base, then we could say that x is equal to 5. Therefore, we could say that the logarithm of 32 to the base 2 is equal to 5. And that is our final answer. Now let's have another example. Let's say logarithm of 36 to the base 6. The same procedure. Let's say that the value of the logarithm is equal to x. So let's say the logarithm of 36 to the base 6 is equal to x. Now this would be our base, the exponent, and then the answer. Then you have 6 raised to x is equal to 36. Now, 36 should be transformed, should be factored out such that the base is 6. Then 36 is equal to 6 squared. Therefore, x is equal to 2. So we could say that the logarithm of 36 to the base 6 is equal to 2. And that would be our answer. Okay, another example, let's say the logarithm of 1 over 64 to the base 2, or with the base 2 rather. So you have the logarithm of 1 over 64 with the base 2 equals x. Then you could have 2 raised to x is equal to 1 over 64. Now, the 1 over the 64, okay, in the denominator, we can make this 64 with the base 2. So we could say, okay, 2 raised to 6. So 1 over 2 raised to 6. Because 2 raised to 6 is equal to 64. Now we are going to make this 2 raised to 6. Okay, put it in our numerator. So we could say 2 raised to x is equal to 2 raised to negative 6. Okay, therefore, we could say that x is equal to negative 6. So this would be our answer. The logarithm of 1 over 64 with the base 2 is equal to negative 6. Okay, take note that since they have the same base, so x is equal to negative 6. So therefore, this would be negative 6 because this is our x. And this is our final answer. Okay, second property, let x and y be real numbers. Then log of x equals y can be transformed as 10 raised to y equals x. So we have to remember that if there is no subscript in our logarithm, that is automatic base of 10. So you have, let's have an example. Transform the given logarithmic equation to exponential equation. The logarithm of 100 equals 2. Okay, this can be transformed as 10 raised to 2 equals 100. Because since this has no subscript, therefore this is automatic 10. Okay. Another, determine the value of x in the given logarithmic equation. Log of x equals 5. Now, since there's no subscript in our logarithm, then we could say that that is 10 raised to 5 equals x. And 10 raised to 5 is equal to 100,000. Therefore, x there is 100,000. Okay. Another properties. Let b and x be real numbers such that b is greater than 0 and b is not equal to 1. Then, the logarithm of 1 to the base b is equal to 0. Okay. And, okay, if b is greater than 0 and b is not equal to 1, okay, we could also say that b, logarithm of b raised to x with the base b is equal to x. So that's the properties. Okay, let's have laws of exponent. By the way, let me expand. Remember that log of 1 to the base b equals 0 can be written as, okay, let's have this one. Okay, since this is the base, we could say b raised to 0 equals 1. Remember that any value, any number that is being raised to 0 is equal to 1. Okay, so that's why we have this kind of equation. Now here, how we are going to have this one? Remember, this is our base. So, b, and this is the exponent, raised to x, is equal to b raised to x. And you have x, since they have the same base, and you have this one. Now take note, if, okay, the base of the argument and the base of the logarithm is the same, then that's equal to the exponent. So that's it. Now let's have laws of logarithm. Okay. The first law would be this one. The logarithm of the quantity u times v with base b is equal to the logarithm of u with base b plus the logarithm of v with base b. So in other words, if the argument has a multiplication operation, then this can be transformed as plus addition. Okay, another. The logarithm of u over v with base b is equal to the logarithm of u with base b minus the logarithm of v with base b. So in other words, if the argument is a quotient, then we can transform that one using subtraction operation. Okay, so take note that the base is being distributed. Okay, they are the same. Now, the log of u raised to v with base b is equal to v log of u to the base with base b. So in other words, this exponent, okay, the exponent is written before the logarithm. So this one. Okay, and we have this one. The logarithm of x to the base b can be written as the logarithm of x with base a over the logarithm of b with base a, where a is not equal to 1 and b is not equal to 1. Okay, if the base and the argument are not the same, then we can express this one, okay, we can express this one as this one, the logarithm of the logarithm of x to the base a over the logarithm of b with base a. So that's it. That's our law of logarithms. Laws of logarithm rather. Let's have, okay, an example. Use the laws of logarithm to expand each expression in terms of logarithms of the factor. So let's say the logarithm of a times b squared. Now since the operation in between the argument is multiplication, then that can be transformed into addition. So the logarithm of a plus, since this is multiplication, so that is plus, times the logarithm of b squared. Okay, since we have squared here, then again, we can use the laws of logarithm. So you have the 2 is being placed before the logarithm b. And that is our final answer. Let's have another example. The logarithm of the quantity 3 over x cubed. Okay, the cube quantity of 3 over x with base 3. Now take note that there is an exponent here. So we could have 3, the logarithm of 3 over x with base with base 3 rather. Since this is division, okay, a quotient, then we can express that one as, okay, the whole quantity, okay. So you have the logarithm of 3 with base 3 minus the logarithm of x to the base 3 times 3. Now, take note that in this case, okay, they have the same argument and base. Okay, since they have the same argument and base, then we could have this one. The logarithm 3 times the quantity of 1 minus log of 3, log of x with base 3. Okay. And distribute the 3 inside the parentheses. So you have 3 minus 3 log of x with base 3. And that is our final answer. Now let's have another example. Let me check first. Okay. Another example. Now, this is, okay, you can read this one as natural logarithm, ln. Okay. But it follows the laws of logarithm. Okay. So this must be read as the natural logarithm of the quantity x times the quantity x minus 5. So since you have a parenthesis here and being multiplied with x, then we can write that one as sum. Okay, as a sum. So the natural logarithm of x minus, plus rather, because this is multiplication, plus the natural logarithm of the quantity x minus 5. Okay, now that is our final answer. Okay, now use the laws of logarithm to condense the expressions as a single logarithm. So what about this one? The logarithm of 2 plus logarithm of 3. Since this is addition, then we can multiply the arguments. So you have the logarithm of 2 times 3. Therefore, we have the logarithm of 6. And that is our final answer. What about the next example? 2 times the natural logarithm of x minus natural logarithm of y. Okay, since we have 2 before the natural logarithm, then we can make this one as our exponent. Okay, so here. Now, since the operation is subtraction, then we can express, the arguments as quotient. So you have the natural logarithm of the quantity x squared minus over y is our final answer. Okay, now what about this one? The logarithm of x squared with base 5 minus 3 times the logarithm of x with base 5. Now, since in this case we have 3 before the logarithm, then we can express that one as like this. The 3 becomes the exponent in the argument. So you have the logarithm of x squared with base 5 minus the logarithm of x cubed with base 5. Now, since we have subtraction in our operation, then we could have the logarithm of x squared over x cubed with base 5. Since they have the same base, in the argument, then we could have subtract the exponent. So you have the logarithm of 1 over x with base 5 because 3 minus 2 equals 1. And that is our final answer. Okay, another. Use the law of logarithm to expand the expression, something this. Okay. So you have, because this is, the operation is multiplication, then this would be addition. And since we have exponent in the arguments, then that becomes the factor. Okay, that is 3 logarithm of 6 with base 5 plus 3 logarithm of 11 base 4. Why did I say 5? By the way, I will read again. 3 logarithm of 6 with base 4 plus the logarithm, 3 times the logarithm of 11 with base 4. And that is our final answer. These are the common mistakes when we have logarithm. Now, Here, the logarithm of 5 plus 2 with base 2. Okay, sometimes some of the students, instead that they have to multiply, okay, since this is addition, it must be multiplication. Okay, so you have the logarithm of 5 with base 2 plus the logarithm of 2 with base 2. So this is not the answer. Okay. By the way, it should not be multiplied, by the way. Okay, so this is not the correct answer. Now another, the logarithm of 5 plus 2 with base 2 is not the same with the logarithm of 5 with base 2 times the logarithm of 2 to the base 2. So they are not the same. Okay, you have to remember that one. And then the logarithm of 5 with base 2, the logarithm of 5 minus 2 with base 2 is not the same as the logarithm of 5 with base 2 minus the logarithm of 2 to the base 2. And then the logarithm of 5 minus 2 with base 2 is not the same with the logarithm of 5 with base 2 over the logarithm of 2 to the base 2. And another, we have the logarithm of the quantity 5 squared times 2 with base 2 is not the same as, so this one is being directly written before the logarithm. So that's not the way. It should be, you have to add first this one, the logarithm of 5 squared with base 2 plus the logarithm of 2, the logarithm of 2 with base 2. Then you can have 2 logarithm of 5 with base 2 plus the logarithm of 2 with base 2. So that is how it should be. So that's all for today.